Okay, so the first question today asks us to graph a system of inequalities. And this is, it's a new topic today, but it's not something that we don't have the skills to do. In fact, I want to remind you of a previous homework problem that we did probably 3 assignments ago. Yeah, it was question 58 from this chapter, and it said graph the inequalities below on graph paper. When I did these, I did them on two separate graphs. That's kind of where we were at the time. And I did find the boundary lines, and I knew if the boundary lines were solid, if they were dashed. What's happening today is instead of just graphing one of the linear inequalities, we're going to graph both. And the solution region is the one that makes both of the inequalities true. In other words, where these regions overlap with each other. So we see that the first one, it has the greater than or equal to. It says y is greater than or equal to 2x minus 4. So that will be a solid boundary line. The other one, y is less than x. That will be a dashed boundary line. So let's start with the first equation, and I'll do this one in this kind of light blue color here. So this will be this equation for this one. And we're going to start at -4, and we have a slope of 2. So at -4, here's our first point, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So we get the idea, right? So that is enough of those points that now I should grab my ruler. I'll just quickly line this up, and there we go. Let's go ahead and just graph this. This is a solid line because it was greater than or equal to. So we'll go and put arrows on each end of this. And it does say that the y values are the things that are greater than that boundary, right? They're above the boundary. And I'm reading this from left to right. I'm being intentional how I'm pointing this out. So the y values are above the 2x minus 4. If I plug 0, 0 into that, it works. Notice that if x is 0, the right hand side becomes -4, y is 0 on the left hand side, so this says 0 is greater than or equal to -4, which is true. So my solution set is roughly these. So I'll just do a few light markings there. It's everything above that curve, above that line, including that line. So let's do the same thing for y is less than x. Y is less than x. Sometimes that kind of, it's like, what's that mean? It just means that, the y values are going to be, if I was graphing the boundary, right, the y values are the same thing as x. Meaning that if x was 0, y would be 0, right? If x was 1, y would be 1. It literally is. I'm graphing this just as the boundary y is equal to x. These would be the same. These would be the same. These would be the same. It kind of indicates that I did not a great job of hitting my line, did I, when I drew the blue boundary line. So these points right here are all on that boundary. Y is the boundary is y is equal to x, but I have to make this a dashed boundary line because it does not include the boundary. So once I'm lined up there, I'm going to go ahead and just dash this line. So dash, 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 dash. And this, it says y's were below that boundary. Can't test 0, right, because it goes right through 0, 0. But you can see that it is the things below, because if I was to pick like a point that's in the region below, like here's the point, x is 3, y is -2. If I put those in there, it would say -2 is less than 3, which is true. So it's all these points below, right, this green boundary are solutions. Now what we care about is we care about the spot where both of these meet. This So I'm going to go ahead and I'll shade this in with the orange. So this is my solution region, right? All of these points below the line y equals x, because those are not included, and above this other curve, right, which was 2x minus 4. It does say, is 0, 0 a solution to the system? How can you tell? Well, if I come in here and I look at 0, 0, it is true that 0, 0 is a solution for the blue curve, right? It's clearly above that, but it has to work for both. And because the line y is equal to x is not a solution, right? Because it says for the second equation or second inequality, it says y has to be less than x. Well, 0 is not less than 0, so it is definitely in the case that this point right here, 0, 0, is not a solution. So how can I tell if 0, 0 is not a solution? Well, I can tell because it does not work for the inequality y is less than x, right? And if for a point to be a solution, it would have to work in both of those inequalities. All right, so that is the system of inequalities. It's the graph, and the solutions are those things that I've that region where I've highlighted in the yellow. Those are the things above the blue line up to, but not including the green boundary line.